All right, next example. Strontium 90 is a radioactive material that decays according to the function A of T is equal to A sub 0 times E to the negative 0.0244 T, where A sub 0 is the initial amount present and A is the amount present at time T in years. Assume that a scientist has a sample of 500 grams of strontium 90. So let's look at the first question. Our first question we have here, what is the decay rate of strontium 90? So let's go back and let's write the formula down again. A of T is equal to A sub 0 times E to the negative 0.0244 T. So the first question is asking us to find the decay rate. And the negative 0.0244, which is which would be our decay rate, is less than 0. Okay, so we have negative 0.0244. My math lab is going to ask you to write it as a percent. So let's go ahead and write this decimal as a percent, and that would be negative 2.44%. All right, so that's A. B, it says here how much strontium 90 is left after 40 years. Okay, so we need to set up this, set up our equation in that we're going to plug in A sub 0, okay, because it says that if you look at the second sentence, it says assume that a scientist has a sample of 500 grams of strontium 90. So that will be our initial amount present. So we have A of T is equal to 500 times e to the negative 0.0244 T. Okay, so it says here after how much is left after 40 years. So we're going to plug 40 in for the variable T. So we have here 500 times e to the negative 0.0244 T, which is 40. And let's multiply 40 and negative 0.0244. And that's, if you can see that, we have 500 times e to the negative 0.976. Okay, so let's answer the question. Okay, let's go ahead and we're going to multiply all of this out. And we have here, let's do base e first. E raised to the negative 0.976. Enter times 500, and we have 188.4076749. And we're going to round to the nearest whole number. My math lab wants you to round to the nearest whole number. So we're going to round this off to 188 grams. Okay, that's how much you have left after 40 years. Okay, so that was example B. Example C. Okay, let's do that one. It says, when will only 300 grams of strontium 90 be left? Okay, so remember it says that our A is the amount present at time t. So the amount present right now we have um, 300 grams. Okay, so we're going to let A of t equal to 300, and we're going to plug it into our formula again. A of t is equal to 500 e to the negative 0.0244 t. Substitute 300 in for A of t. So we have here 300 equals to 500 times e to the negative 0.0244 t. We want base e by itself, so we're going to divide by 500 to both sides. And 300 divided by 500 is 0.6, is equal to e to the negative 0.0244 t. And solving for t, okay, we're going to take the natural log to both sides. Right hand side is negative 0.0244 t is equal to ln of 0.6. We're going to divide by negative 0.244 t to both sides, negative 0.0244, in solving for t. And let's see what we get here. So ln of 0.6 divide by negative 0.0244, enter. And we're going to round to the nearest tenth here. So you see we have 20.93547638. Round to the nearest tenth, 20.9. So the question again, it says, when will only 300 grams of strontium 90 be left? 20.9 years. All right. Our last example, D, or last question here, D. It says here, what is the half-life of strontium 90? Okay. Well, if it's telling us initially that the scientist has a sample of 500 grams of this radioactive material, then half of 500 grams is going to give us 250. So that will be our A of t. Okay, so the amount that's present at the time. So we're going to go here again, plug it back into our formula. So we have 250 equals to 500 times e to the negative 0.0244 t. We're going to divide by 500 to both sides. And we have 0.5 is equal to e to the negative 0.0244 t. Take the natural log to both sides. Right hand side, we have negative 0.0244 t equals to the ln of 0.5. Excuse me, zero point 0.5. Let's divide. And we have t is equal to, and we're going to round to the nearest tenth for this example as well. So let's go ahead and type this into the calculator. ln of 0.5 divided by negative 0.0244. So we have 28.40767133. Round to the nearest tenth, we have 28.4. So the half-life of strontium 90 is about 28.4 years.